to start off with a little bit of politics, something that doesn't usually happen at these type of conferences. However, it's big news in the UK for sure. The UK has voted for a Brexit, unfortunately, so this idea of collaboration, scientific endeavour, working together, internationalism, all of these wonderful things, seems to have been pushed to the side in the UK at the moment, unfortunately. This is an interesting map of the way the voting went. This large yellow part at the top represents the 32 voting regions of Scotland, and yellow means Remain. So if you ever wanted to see a better example of politics, the difference in politics between Scotland and England, who very predominantly voted Leave, there it is. So what this really means is Scotland in the very near future will be looking for the support of our European partners to be an independent and productive member of this forward-thinking European community. And to use the words of our Scottish MEP in the European Parliament a couple of days ago, Scotland did not let this model down, and we're looking towards our European partners not to let us down either. Okay. Now, today we're going to cover cloud evolution as I sort of work that into where we are now, and speak about some work in the DICE project, also reference the CACTOS project, and do some collaboration exercises with the DICE project. Arrived at the area of containers. Originally we were going to do a deep dive in containers, but I decided against that and to sort of concentrate on something that we're working on just on behalf of the DICE project for projection. So cloud evolution. This guy here, I'm certainly old enough to remember doing all this stuff. Local desktop machines, that's where we used to be. So give me a back. He's probably got Windows installed here and has been forced to reboot once again. This will be familiar to some of you for sure. As far as you could really go in this situation would be the separation of hard drives and logical areas on that. There's not really a lot you could do. We evolved beyond that to sort of traditional data centre hosting. I worked for many years for a hosting company, so that was my field of expertise. But in order for a service provider to take something to market in this situation would typically take 6 weeks. That would involve a representative from a hosting company, the service provider talking to these people about their needs, trying to understand them, work out the kind of hardware they would need, ordering all of that hardware from an IBM or Dell or HP, waiting for that to be delivered to that data centre, having some idea of the real hands installing it there, configuring the networking of it, installing the services, eventually handing over. Typically 6 weeks. From then, things started to get a lot more efficient with the advent of virtualization. Virtualization, of course, is what gave us the opportunity to use hypervisor technology, which was the building block of the early clouds. I was lucky enough to work for the company that released the very first public cloud in Europe called Flexiant. But from that point, I mean, the cloud now is a very different thing. I mean, you can almost forget about the cloud. I mean, it's becoming a hidden commodity somewhere away in the back end. Companies who want to host their services don't want to think, cloud, what is it, how do I use it? They want to say, here's my application, somebody take me by the hand and cloudify it and just make it work for them. So from there, things get more efficient with the advent of containers, great use of hardware resources. Docker's a good example of that. More recently as well, Google open sourced their Kubernetes technology, which was pretty fantastic. This gives you the opportunity to then manage Docker installments. It's, in case anyone doesn't know, it's a cloud agnostic open source tool now that you can use containerised technology in a way that's completely self-healing. It can heal the way you want it to heal. If you want 140 web servers running and 15 database servers and 15 geographical regions, you very, very simply enter regions to manage that for you and it will do it for you. So very, very, very clever, and this can work across different clouds as well, which is very useful indeed. You can use load balancers in this setup to make sure you bring services close to where the demand is as well. So that's really the starting point for where a lot of the most recently funded European projects work in the IT area. One of those is DICE. It's a quality-driven development of big data applications, such as those provided by use partners who use effective co-develop, uses UML profiling tools for software designers to effectively reason about the reliability and safety and efficiency of their data-intensive applications. Uses monitoring and anomaly detection, trace checking, and an agile delivery approach. The main advantages of that, DICE really aims at tackling skill shortages. The steep learning curves involved in that whole area, quality-driven development, shortening time to market, time is money, as they say, always important to people. Things can just be launched very quickly without additional overhead, reducing the number and severity of quality-related incidents, and this really is then where our tool comes in to reduce those incidents. Everyone loves that. So Flexiant within that project are developing something called a fault rejection tool. What that does effectively is enables a controlled causing of cloud platform issues such as stress or service outages, issues with virtual machines, the purpose being to observe the subsequent effect of those deployed applications. It's largely been designed in conjunction with the idea of a DevOps workflow, tighter correlation between application design and the deployed operation, not limited to that.
Can you speak a little bit louder? We don't have a microphone, so...
It is a microphone.
I don't think so.
Sure, I can certainly speak a little bit louder. So overall what it does is help improve the sort of resiliency of these data-intensive applications by bringing together things like fault tolerance, stress testing, and benchmarking, and the idea of a single tool. So in this area I'm going to cover the motivation of it, something about the innovation, the design, and give an example of how you would actually run it. Motivation-wise, there's a projected growth, of course, as I'm sure everyone in this room realises, in the big data market, especially for data centre owners. This is very important. Cloud service providers, application owners, and they're demanding data-intensive requirements. All of these entities are beneficiaries of this tool. When it comes to the application quality of service, the resilience of those applications is largely dependent on the underlying infrastructure. And this is really the point. So with this fault injection tool, the data center owners can gauge stress levels of the infrastructure and thus offer advice to their customers. They can identify and address bottlenecks. They can even adapt pricing in conjunction with various levels of assurances because they understand their application. And from a developer perspective, they can evaluate the application resilience and dependability, which which can be demonstrated only really at runtime through forcing parts of their application to fail. And other than the DICE project, another area that we've expanded the fault injection tool out to is the CATTOS project. The CATTOS project is a relatively simple project. I think it's more simple than this diagram identifies, but we have a cloud platform up in the right there with a tool called CATTOScale that measures, it takes in lots of metrics from the cloud platform at various levels. Those metrics are used to build up externally to the cloud platform various models of how the cloud platform looks. From there, optimizations can then be run on the cloud platform, things redeployed accordingly. It's a simple concept, but very, very practical. And within the CATTOS project, we expanded the fault injection tool to automatically pick off and trigger these optimization algorithms, for example, by causing stress in specific applications. For example, we use YCSB to effectively stress MongoDB environments and then pick off this feedback loop and then redeployments that will be done then in an optimal way, for example, consolidating where things are, automatically shutting down physical nodes to save energy, this type of thing. When it comes to the innovation side of things, it's probably largely Chaos Monkey that inspired us to do this, but a tool like Chaos Monkey, because there is other tools out there, Chaos Monkey only accesses Amazon Web Service instances, and it's the ability to terminate VM, so we go way further than that. Cobra is something that was also developed at Imperials. It's not supported, it also suffers from very high resource usage practically when you actually install it and try and use it. It's very complex configurations and it's pretty limited in the way you can extend it and add things to it. Whereas the aim really for us is to provide a sort of component for quality-driven development of applications and cloud software stacks, leading to that idea of reliability of these big data applications and IoT solutions. It's lightweight, importantly it also installs any required tools and needs automatically in the dependencies as well. And it's been specifically designed with future extensibility in mind as well. So when it comes to the design side of things, this really is sort of logically how it looks. The architecture itself runs completely independently and externally to any of the target environments. It uses something called JSCH to SSH to virtual machines. It then issues the command as a predefined user. We've also open sourced this as well, so it's been released under the Apache 2 license, and we've tested it using various OS configs, Ubuntu 14, 15, 10, CentOS, also CentOS version 7 will be also tested as well.
Speak a little bit louder again.
Sure.
You're slowly smoothing out and then nobody can hear you.
We're also looking to extend this out to Windows environments also. So an idea of some of the supported type of faults that we can handle. So as a cloud administrator, there's various operations that you can do, such as the ability to shut down a node to see the effect on a cloud installation or a cloudified data center. It's always interesting to shut down various things and see the effect in other areas. looking from that tool, we can implement the idea of high CPU usage in certain nodes and see the effect in perhaps a distributed application, which is interesting. It can cause high bandwidth uses at various networking areas also. And a virtual machine admin as well, so a different level, again, of usage for the platform. Good. Better, everybody? Yeah. Excellent. I like to be heard anyway, so that's good. I'm happy about that. So a virtual machine admin is another level that tool operates at, with the ability to shut down maybe a random virtual machine that's part of a distributed application deployment and then start measuring the effect and what's happening with your application. Causing things like high CPU and memory usage for the virtual machine, whether it's a web server or your database server, and start to measure operation from that moment. Blocking external access, again high bandwidth usage around the virtual machine area, and even causing disk usage is something we're looking at the moment in our self-storage backend in our cloud platform. We're looking to plug into that to really, shoot up the I/O and understand the effect in applications. Of course, shutting down things. This one here, the YCSB MongoDB, was the part I mentioned that was specifically extended out for the CatCos project as we look at specific applications. So yeah, it's quite a well-rounded tool.
Can I ask a question?
Sure.
High memory usage is not a fault. It is something that you should correct during runtime. Rather than shutting down a VM, you should be able to have elasticity and do a load balancing.
Automated elasticity is another approach towards it. In fact, it's not even an alternative approach. It's something that can be, they're not mutually exclusive things. It can certainly also be done. But if you think of an environment, a shared environment of a public cloud, for example, where someone has deployed their application there, and through no fault of their own, someone else could be causing high memory usage, for example, in that physical environment that they're deployed in. Certainly one way you can handle that is by looking at elasticity, but to do that properly is very, very complicated, and in fact is where you need things like CatCos to come in to understand the entire cloud environment and initiate redeployments. It's very different if you own the entire cloud infrastructure. If it was a private cloud, things are very, very different. This largely, I would say, is more fitting for public environments, but even in a private environment where they were running various tools in conjunction with each other, it's still very, very useful. An example of things being used practically, it's a command line tool. So we would look something like that. You can invoke actions on the virtual machine or cloud platform automatically. So as I mentioned earlier on, it then installs any required tools in that target cloud platform. It means that's one of the clever things about it. All dependencies would be automatically covered as well. It can even evoke any APIs that would be needed as well. There's a wealth of command line switches involved. I won't cover all of those, but stressing the memory is the example here. Dictating the amount of RAM and an operating system and target address. And from there, you were then to measure what was going on, just as the simplest possible example. Running a call in a real system, so the tool's connected via SSH to the VM. It's determining the operating system by checking say releases, and from there it's look to see if the memory stress tool suitable for an Ubuntu environment is available. In this case, which would be mem tester. If it's not found, it will be installed automatically with the dependencies. And finally, it then calls mem tester to saturate the memory of the target node. And the figure quite simply shows then the result of doing that is detected by your favourite monitoring tool, and then shows nearly all of the 2 gig of RAM available being saturated. So the conclusion of that and the sort of future work. So to conclude, it's a very easy to use and easy to integrate command line tool. It's very extensible. The future work will aims to examine developers using quality-driven DevOps approach, testing applications, failing infrastructure, misbehaving services. What we're trying to sort of move along in time with the way cloud platforms are evolving. Covering difficulties, possibilities of extensibility of external users, investigating all of the limitations. We're looking to consider various topologies, as many operating systems as required, completely vendor agnostic when it comes to infrastructure, but we've still got a lot of testing to do there. I mean, we're looking to commercialise this tool, although we're open sourcing it, and we think it has a lot of value and can be used along in conjunction with support contracts, for example. We're also going to be investigating heavily, this is something we're looking to do next, is use this tool in containerised environments. That will certainly be a future target to help understand the effect on microservices, which is a very new thing, and I mentioned earlier on containerised services, the use of Docker, the use of Kubernetes, and really what that means is the cloud platform, as I say, is very much in the background now. The cloud platform it's never way up here because you have this idea of the containerised environment, and you have the IoT paradigm sort of meeting it right there, and the idea of the IoT paradigm using microservices efficiently. So this is really where we're sitting, and for us as a company as well. And the fault injection tool, the idea is to cover all of that area. So that's it. If there's any other questions, I would be happy to take them. About the Cactus project, DICE project, fault injection, cloud technologies in general, which is my new field of expertise.
That sounds.
Thank you.
There are some questions. 1, 2 questions, please. Something asked, yes.
So how would that work in practice? I have to admit I didn't understand quite everything.
Yeah.
But how would that work in practice? If I would be interested in testing cloud service that I either provide or that I want to use, would I come to you and give you a phone call, or would I download your tool and do it myself? Would an expert come to me and test it in my environment, or how would it work in practice?
It's a good question. It's open source, so the choice would be yours. I mean, so you'd have the ability to take the tool, use it yourself with no help. That there is instruction there about its functionality, its capabilities, how it should be operated. On the other hand, I think the way the market's working, that companies, when they want to cloudify their technologies, really want held by the hand, and it's something we've realised a lot over the years, that it's very important. You can't just hand someone a cloud environment and say, there's a nice GUI, go install, and run your application, and because people are just scared of it and they don't engage properly. So you have to really take these people who understand their applications and say, we will use something like the fault injection tool to help us understand the environment, understand your application, understand the limitations, feedback, advice to you about how better you can, maybe amend your application to be fit for purpose for a cloud environment. So that idea of the added level of support is what was referring to really when I says there's opportunity there, a business and commercial opportunity to provide that.
I'm looking around for an additional question.
And the name of the tool is Fault Monkey. So if I want to search for the open source tool, what do I have to search for?
At the moment it's just called the DICE fault injection tool. Renamed from Flexiant Monkey, which was too much like Chaos Monkey. Chaos Monkey is Netflix's tool, so it was originally we called it Flexi Monkey as a sort of working name, but it's now just because we designed it within the DICE project and worked there, at the moment it's called the DICE fault injection tool.
Please take your other question in the coffee break. I'm sure we can improve our discussion and integrate the topics you mentioned with microservices and the last topics. Thank you very much again.
Thank you very much.
Before we start with the news session, just a little announcement. So the afternoon